Alright guys, welcome back to my channel. Today in this video, I'm going to talk about one of the factoring technique that we use to factor something like this, right? A trinomial like this. The method is called it's slide and divide. Slide and divide. Okay, so I'm going to show you how you can factor this, especially when the leading coefficient is not 1, right? We have 3x squared minus 10x plus 8. How we can do this, how we can factor this using the slide and divide method, and I'm going to show you the rationale behind the method, because the method, when you first look at it, this doesn't really make any mathematical sense. You'll see why, right? So let's, without further ado, let's get right into it. The first step is we're gonna multiply the 3 by the 8, okay, which is the sliding, right? The sliding process. We slide a 3 over, we multiply by 8, and then we're gonna get x squared minus 10x, right, plus 24. 3 times a is 24, right? So there's no longer a 3 here, and then 3 times a becomes 24. Now be careful. I want to make a comment here. All right, you don't want to put an equal sign here. I know that when you use other ways to factor this, you might want to put equal. Maybe you have a habit of putting an equal sign throughout the process, but here you don't want to do that, because if you look at this expression, if you look at this trinomial, they're not really equal, right? We have a brand new expression. They're not really equal, so don't put an equal sign, right? But at the end, we'll be able to factor this, and maybe we can put equal sign at the end. Okay, so now everyone knows how to factor this, right? This is a simple case where the leading coefficient is 1. Okay, the slide and divide method is used to factor something that's, when the leading coefficient is not 1. And then we can factor this, right? We can factor this. We try to find two numbers and multiply to 24 and add up to -10. I think in this case, so let me just put the x in there. And I think in this case, we'll have -4 and -6, right? This we know how to do, right? It's the simple case. And then what I am gonna do next is I'm going to actually, let me rewrite this again. I'm gonna divide both numbers by 3. Why 3? You might be asking. The 3 is coming from the leading coefficient here. This is the dividing part, right? A slide and divide. This is the dividing part. We're gonna divide the two numbers by 3. Okay. I know. As so far, if you look at this, it doesn't make sense at all, right? It doesn't make sense at all. But we'll see. At the end, we'll actually be able to factor this. Okay. So now, when you do 4 minus 3, right? 3 doesn't really divide 4 evenly. So if it doesn't divide evenly, then what you're gonna do is you're gonna just bring the 3 to the front. 3x minus 4. Another sliding process, right? Another sliding, right? If 3 doesn't divide this number, if 3 doesn't divide this number evenly, you're just gonna slide this to the front, right? It becomes 3x minus 4. And then now when you look at 6 divided by 3, well, 6 can be divided by 3 evenly, right? It gives you a nice integer, which is 2. Just write that down. You don't have to slide, right? If the number here divides into the number here, you don't have to slide it over. And there we have it. That's the factor form. Now we factor this into 3x minus 4 times x minus 2. Maybe at the end, we can put an equal sign here and say, okay, this is equal to 3x minus 4 and x minus 2. When you look at all these steps, right, it doesn't really make sense mathematically throughout the entire process. Why do we slide this over? Why do we divide by 3 here? Why did when it doesn't divide, we slide to the front, right? It doesn't really make sense. But if you actually check this, multiply out the terms, expand it actually gives you back this. So they're actually equivalent. This method actually works. Now here comes the second part of the video. I'm going to show you why this shortcut, right? This is like a shortcut. Why this shortcut works? Okay. Actually, if I show you all the steps, basically this shortcut it took out a lot of steps in between, right? It looks like there are only. Let me label the steps. We have step 1, we have step 2, we have step 3, and then at the end we have step 4, which is the answer. It looks like we only have 4 steps here, right? But there are actually a lot more going on in between. The shortcut really took out all the steps in between, and it just show you the crucial step that you perform to get the right answer. So now I'm going to show you why this shortcut actually makes sense. I'm going to show you all these little steps in between the method that they don't show you, that you don't do. during the process. Okay, first I'm going to multiply this trinomial by the leading coefficient, which is 3. Okay, I'm going to just multiply by 3. And then now I'm going to distribute a 3 to all three terms here, and I'll get 3. So 3 times 3, that's 3 squared, right? X squared, and minus 3 times 10x, and plus 8, right? Now, before I move on, keep in mind that here I multiplied this trinomial by 3. I just changed the expression, right? At the very end, I'm going to divide everything by 3 so I can get back to this original problem, okay? But now just follow this for now, okay? Now 3x squared times x squared, I can rewrite that as 3x squared, right? I can write that as 3x squared. And minus, now I'm gonna just change the order here. I'm gonna do 3x and then times 10, right? This is 3 times 10 times x. Multiplication is commutative, so I can change the order around, it's okay, right? And then plus 8. Now, right over here, I'm gonna put a parentheses around 3x. Now, as you can see, we have 3x, 3x. So why don't we introduce a new variable here to represent this 3x? So let's call this y. Let's call this y. So actually on the side, I'll write let 3x equal to by, right? So I'm going to replace 3x with y, right? So I can basically simplify the look of this expression, right? Then we'll have y squared. I'm going to replace 3x with y, so we'll have y squared minus y 10y basically plus 8. Now, if you look at this, and if you compare this with our first, hold on a second, I forgot to multiply by the 8 by 3. It's going to be 24 here, right? Okay, so now if you compare this, even though they have different variables, right? Don't worry about that. They have the same look, right? All the coefficients match up. Now, I'm going to keep going. I'm going to factor this, y, and we know that this will be factored into y minus 4 and y minus 6. And this matches with our second step, right? If you look at it. And now, remember what our y is, right? Our y is really 3x. So I'm going to replace 3x back in the expression. Right? I'm going to replace y with 3x. Then we'll get this. Now, remember at the beginning, we multiplied by 3, right? So if I want to go back to the original expression, I have to undo the multiplication of 3 by division of 3. I'm going to divide this whole thing by 3. And let's simplify this a little bit. Now, 3x, if you look at 3x minus 4 and 3x minus 6, here we have a common factor, GCF of 3, right? Let me factor this out. We have 3x minus 4. And then I can factor out a 3 here, right? I can factor out a 3 here. And then we'll have x minus 2 in the parentheses. And as you can see, right, 3 and 3, they divide out. So at the end, minus 4 times x minus 2, which matches with our last step. My mark is fading, but I think you guys can see it, right? There you go. So this is actually what is going on behind the scenes, right? So we took out all the little steps. We saved the important steps that we can perform to get to the factor form. Thank you guys for tuning in. I'll see you guys in the next video. Peace.